Okay, let's look at balancing redox reactions in a basic solution. In order to balance the redox reaction, we need to follow a set of rules. First thing we need to do is write an unbalanced half reaction for the oxidation and reduction components of that redox reaction. We then need to balance the atoms within those half reactions in a set order. We balance the atoms except for hydrogen and oxygen, first of all. We then balance the oxygen by adding water to the deficient side. We then balance the newly created hydrogen atoms by adding hydrogen ions on the opposite side, which will also be a deficient side. Our fourth step, which differs from our neutral or acidic solutions, is that we must add hydroxide ions to both sides to neutralise the hydrogen ions and produce water. We then balance for our charge in our half reactions. We then use lowest common multiples to balance those electrons that we've created in both the half reactions. Once we've done that, we can add the two half reactions together. Once we've added those half reactions together, we can simplify the overall reaction by subtracting common species from both sides. And finally, to check that we have a fully balanced redox reaction, we check for mass, in other words, all of our atoms, and the charge on both sides. And this ensures that we have conservation of both mass and charge. So let's look at an example. And you'll always be told that you have a basic solution. So if we look at our cyanide ion reacting with our permanganate ion, we get a cyanate ion and manganese dioxide as a product. In order to create our half reactions, we need to put our oxidation states for each atom within that reaction. So if we look at our cyanide, nitrogen will be -3, leaving us with +2 for the carbon to give us an overall charge of -1 on the ion. For our permanganate ion, the oxygen will be -2, giving us -8 overall. We have a -1 charge, which means our manganese must be +7. Our cyanate ion, our oxygen must be -2, our nitrogen -3, which means that our carbon must be +4 oxidation state. And our manganese dioxide, our oxygen will be -2, meaning that our manganese must be +4. So we're now in a position to determine our oxidation and reduction half reactions. So our carbon goes from +2 to +4, so it must be oxidised. So we write that as our oxidation half reaction. Our permanganate ion, the manganese within the permanganate ion, goes from +7 to +4, so it is reduced. So we can write that as our reduction half reaction. We said in step number 2, we now need to balance for all atoms within those two half reactions. So let's take our first reaction. Our first step was to balance for all atoms except hydrogen and oxygen. So carbon and nitrogen, we've got one of each there. We've got one of each on the right-hand side, so we don't need to balance that. Or, sorry, it is balanced. We don't need to add anything to either side. So we start off with balancing our oxygen. And we notice on the right-hand side that we have one oxygen, so we have to get one oxygen on the left-hand side, so we add a water molecule to that deficient side. However, we're now left with an excess of hydrogen ions on the left-hand side, and we have to get hydrogen ions on the right-hand side, and we do so by adding 2 lots of hydrogen ions in this case. The problem here is we've got a basic solution, and we don't get hydrogen ions existing. So we now have to add hydroxide ions to both sides. But we must add the same number to both sides. So we've got 2 lots of hydroxide on the left, balanced with 2 lots of hydroxide on the right to neutralise the hydrogen ions to give us water. So if we look at our overall equation, we've got 1 lot of cyanide plus 1 lot of water plus 2 lots of hydroxide gives us 1 lot of cyanate plus 2 lots of water. Now at this stage we've got a common species on both sides. We have one lot of water and two lots of water, so we can cross out the water from this side, cross out one of the waters from the right hand side. So our finished half reaction is one cyanide molecule plus two hydroxide molecules gives us one cyanate molecule plus one lot of water. We can do the same thing with our permanganate to manganese dioxide reduction half reaction. First thing we need to do is balance for all atoms except for hydrogen and oxygen. We've only got one, and that's manganese. We have one atom of manganese on the left, one on the right, so that's now balanced. So the second step is to balance our oxygens. We have 4 on the left-hand side, 2 on the right-hand side, so we have to add another 2 on the right-hand side, and we do that by adding water molecules. 2 lots of water molecules gives us 2 more oxygens, so we've got 2 plus 2 gives us 4 overall. That leaves us with an excess now of hydrogen on the right-hand side. So we have to add hydrogen ions to the left-hand side. And we add 4 of those to balance the 4 on this side. So our reaction has 4 lots of hydrogen ions on the left, 4 lots of hydrogen on the right, except in a basic solution, we can't have hydrogen ions present. So we now have to neutralise those 4 hydrogen ions by adding 4 lots of hydroxide ions to the left and to the right. So if we do that, we can do 2 steps at once now. We've got 4 lots of water molecules here, 2 lots of water molecules on the right hand side, which leaves us with an excess of 2 water molecules on the left, none on the right. So our full reaction, or full half reaction for our reduction reaction, is 1 lot of permanganate ions plus 2 water molecules gives us 1 lot of manganese dioxide plus 4 hydroxide ions. We're getting closer. Step number 3 in balancing our redox reaction in a basic solution is to add electrons to both sides to balance the charge. So if we take our oxidation half reaction, our cyanide plus 2 hydroxide gives cyanate plus water. We've gone from a plus 2 state to a plus 4 state here, so we've given up 2 electrons. Our manganese plus water gives manganese dioxide plus hydroxide. We've gone from a plus 7 state to a plus 4 state, so we've had to absorb 3 electrons. So our full reduction half reaction is 3 electrons plus the permanganate ion plus 2 lots of water gives us manganese dioxide plus 4 lots of hydroxide. Step number 4 says we need to balance the electrons on both sides. So if we have a look, we've got 2 electrons and 3 electrons. So we'll need to multiply the top one by 3 and the bottom one by 2, which gives us 3 cyanide ions plus 6 hydroxide ions, gives us 3 cyanate ions plus 3 water molecules plus 6 electrons. And our second half reaction, we'll get 2 times the 3 electrons to give us 6 electrons, 2 times the permanganate ion to give us 2 permanganate ions, 2 times the water molecules to give us 4 water molecules, 2 times the manganese dioxide to give us 2 manganese dioxide, and 2 times 4 hydroxide ions to give us 8 hydroxide ions. We can now add the 2 half reactions together. So we get 3 cyanide molecules plus 3 cyanide ions plus 6 hydroxide ions plus 6 electrons plus 2 permanganate ions plus 4 water molecules gives us 3 cyanate ions plus 3 lots of water plus 6 electrons plus 2 manganese dioxide molecules plus 8 hydroxide ions. We're very close now. What we can do is subtract common species from both sides. So if we have a look, we've got 6 electrons on the left, 6 electrons on the right. We have 6 hydroxide ions on the left, 8 on the right. So we subtract the 6 from there, we cross out that one. We've also got 3 lots of water on the right, 4 on the left, so we're now left with 1 water. So our final reaction is 3 cyanide ions plus 1 water molecule plus 2 permanganate ions give us 3 cyanate ions plus 2 manganese dioxide molecules and 2 hydroxide ions. Let's check how we went. And we do that by balancing the number of atoms on the left and right hand side and the overall charge on the left and right hand side. So we have 3 carbons on the left, 3 carbons on the right. We have 3 nitrogens on the left, 3 nitrogens on the right. We have 2 hydrogens on the left, 2 hydrogens on the right. We have 9 oxygens on the left. We get 1 plus 8 gives us the 9. We have 3 plus 4 plus 2 gives us 9 on the right hand side as well. We have 2 manganese on the left, 2 on the right, and now we need to work out our charge. We've got 3 times minus 1 plus 2 times minus 1 gives us minus 5 overall on the left hand side. We've got 3 times minus 1 plus 2 times minus 1 on the right hand side, so we know that that's a fully balanced redox reaction.